Hello everyone, I'm Ali Khawari Khorasani and I want to present to you tangible user interfaces for learning and organizing information. First of all, we have introduction, then I speak about three articles, then I have future work for you, and in the final we have conclusion. In the first article, we have a good definition of tangible user interfaces. They allow users of computer systems to interact with digital content through the manipulation of physical objects. Many applications have been developed in a great variety of domains and tasks, such as color mixing activities, digitally augmented paper and books, and literacy development. These are only a few examples of using the tangible user interfaces in education. The first article is about benefits of the tangible interface for collaborating, learning, and interaction. The goals are an investigation of the role of tangibility in a problem-solving task and also comparing the use of a tangible and a multi-touch user interface in a problem-solving activity. In this article, we have a comparison of tangible and multi-touch interfaces. Both tangible and multi-touch interfaces have their own strengths and weaknesses. In some contexts, users will benefit from the flexibility of the visualization of a multi-touch interface, while physical objects may provide a faster and more direct way to explore a problem space. Tangibility may positively influence learning by improving several process variables including collaboration, integration of representations, exploration, and also playfulness of the tasks. In this article, they use Tinkerlamp. The Tinkerlamp is a tabletop learning environment. Users place a small-scale shelves as well as loading and expedition docks on the table to lay out a warehouse. A camera recognizes the position of the objects via fiducial markers. An augmented reality system uses this information to project additional information on top of the warehouse via a projector. Results of this experiment provided evidence that logistic apprentices better solve a warehouse design task with a tangible interface than with a multi-touch interface. The results of this article tells us that tangibility helps apprentices perform the task better and achieve a higher learning gain. Also, groups using the tangible interface collaborated better, explored more alternative designs, and perceived problem solving as more playful. The main um, the main impact of tangible interfaces is the promote constructive behavior, exploration, collaboration, and playfulness of the task. The second article is about a tangible interface for organizing information using a grid. The goals are presenting a tangible interface platform for organizing conference papers and also comparing it to both graphical and paper interfaces. They have developed a new platform and tangible user interface for manipulating, organizing, and grouping pieces of information. They attempt to combine the physical and digital representations to exploit the advantages of each. There are some plastic tags or pucks On the board that they contain a small RFID tag. Each time the user moves a puck, the board sends the identity and the grid location of each of the pucks in the grid to a computer on a serial port. They coupled this system to a computer driving a video projector which projects general information onto the board and specific information onto each puck. The view detail command puck has a larger projectable surface than the data pucks. It allows the user to view additional information about a given item. For applying the group command by placing the command puck over the first of the items to be grouped. In this slide, you can see that when papers on similar topics are presented in parallel, color-coded lines are drawn between conflicting papers. The results of this article suggest that tangible interface can provide a more effective means of organizing, grouping, and manipulating data than either physical operations or graphical computer interaction alone. The third article is about using theories of cognition and learning to inform tangible user interfaces design. The goals are creating a tangible learning design framework, presenting a taxonomy of 5 elements to design tangible user interfaces for learning, and also using theories of cognition and learning to generate guidelines. Design frameworks are a form of design knowledge that designers can use to create interfaces and systems that users find efficient, effective, or beneficial in other dimensions of user experience. They also provide a common language for designers and researchers to discuss design knowledge, generate prototypes, formulate research questions, and conceptualize empirical studies. In this article, the authors formulate the framework in two parts. First, they have compiled a taxonomy of elements of tangible user interfaces design, important to consider with respect to learning. Second, they have generated a set of 12 guidelines to inform the design of these elements and have mapped the guidelines to the design elements that they inform. As you can see in the picture, the 5 elements of taxonomy are physical objects, digital objects, actions, informational relations, and also learning activities. In this slide, you can see the table of 12 guidelines with reference to tangible user interface elements to which they apply. We have different perspectives such as info processing, constructivist, embodied, distributed, and collaborative in this table. There are some future works in this issue. For example, the first guideline presents theoretical implications of cognitive load theory for tangible user interfaces on the basis of research that is extensive but conducted primarily in traditional computer-based learning environments. Future work is needed to explore the test and to explore and test these implications, specifically in tangible user interfaces learning context. Also, we need conduct more research in order to refine and expand the guidelines and creating more advanced tangible learning design frameworks. In conclusion, we can say that tangible user interfaces are a computing paradigm in which the real world is augmented by embedding computation into physical objects and environments that are linked to digital representations. Many theoretical points of view make us think that tangibility may positively influence learning by improving several process variables, including collaboration, integration of representations, exploration, and playfulness of the task. And these are the references of my articles. I will be glad if you have any questions, I will answer you. Thank you.